Okay, from the last video we ended at this point right here, but what we can do is simplify this part too. So now that there is no exponent here, I can now distribute this into those parentheses. So that's going to be negative 3x to the 4th times 4x, give me negative 12x to the 5th, plus 6x to the 4th. Also, since there is no exponent here, I can distribute that 4 inside those parentheses. Now at this time I can combine any like terms. So I'll bring my GCF down, and then the x to the 5ths I can put together. Alright, and this would be as simplified as I can get it. You don't want to distribute those together, just keep your GCF separate and simplify what's in here as far as you can. Okay? Let's look at the next problem. Alright, the next problem on my paper says find the equation of the tangent line to y equals x squared minus 3x plus 5. And then we want to know at the point. So remember, when you're doing derivatives, what you're finding is the slope of the tangent line to the function, to the graph of the function. What we're asked to find is the equation. So when you're writing an equation, what you need is a slope and a point, and then use point-slope form to write the equation of a line. So first what we need to do is find the slope, and we do that by taking the derivative. So we would say the slope, or y prime, would be 2x minus 3. That is now my slope. And it wants to know specifically at this point. So I'm going to come in here and fill in an 8 in place of x. Alright, and that tells me that the slope of the line is 13 at the point 8. This would be at any point, and then specifically at the point 8 it is 13. Now that I know the slope, I can use point slope form, which is y minus y sub 1 equals m times x minus x sub 1. And the x sub 1 and y sub 1 are a point. The m is the slope. So they've given us a point, and we just computed the slope. We plug in y minus the y coordinate, which is 45, equals the slope, times x minus the x coordinate, which is 8. Then we just simplify. So we would have y minus 45 equals 13x. Well, let's see, 13 times 8 would be negative 104. Then I add 45, so some basic algebra stuff here would give me y equals 13x minus 59. And this would be the equation. And so notice, usually in my math lab, they're going to give you the y equals part. So all you would need to type in is the 13x minus 59. Right? If it asks for the equation, this is the equation. It asks you to find the slope. This would be the slope. This is the slope at a specific point. Okay. The next problem asks us to find the derivative of y equals sine to the 5th power x. So this right here is one of the notations for derivatives. Remember, there are a variety of ones. D sub x, f prime of x, y prime, different varieties. So this wants us to find the derivative of y with respect to x. So when I look at it, let me go ahead and just write it down here. Alright, this is a trig function. Now notice it doesn't just say sine x. Okay, it says sine to the 5th power x. So you can't use your standard trig function derivatives. We have to use those special ones with the chain rule, because this doesn't meet that specific sine x. It has other things involved. So we will take the derivative, All right, and using the chain rule. So this right here is the parent. So we will say 5 sine subtract 1. So the derivative of the parent, now the derivative of what's inside, so the derivative of sine would be cosine x. So first take the derivative of the mother, then the derivative of the baby, if that helps out. Alright, so the main function, use the power rule, then take the derivative of what's inside. And that would be as far as you could take that one. Alright, the next problem asks us to find. Alright, notice this one's a little bit different in that it has a 3 there and a 3 there. You can't see my paper. Let's move that over. Alright, what that is saying, it wants to know the third derivative. So to find the third derivative, you have to get through the first derivative and the second derivative. So let me write the problem down here. Y equals 7x cubed plus 8x squared plus 4x. So we will find the first derivative. Alright, and here we're just going to use the power rule. This is a sum and difference, so I take each term individually. So I'll look at each term and apply what rule is necessary for each individual term. For the first term, 7x cubed, I can use the power rule. Multiply by the exponent 3, so that'll give me 21. Take 1 away. And that's all I can do on that one term. Then I look at the next term. What rule can I apply there? The same rule. 2 times 8 is 16. Subtract 1 from 2, I get 1. Move to the next term. Same rule applies. 4x derivative would be 4. Alright, now this is the first derivative. To get to the third derivative, we first have to find the second derivative. So I'll take the derivative of the first derivative. So I'll say 2 times 21 is 42. Subtract 1. 1 times 16 is 16. X is gone. So to get to the third derivative, we take the derivative of the second derivative. And 1 times 42 is 42. When I take 1 from there, the X is now gone. Alright, the next question asks us to find the derivative by using implicit differentiation. And so implicit differentiation is something that you saw in the very first problem, in that we're taking the derivative to a certain variable, and if we encounter a different variable, then we have to use that d over dx. So let's look at this problem here. Alright, so in this problem, we're going to take the first term and take its derivative. So look, this is a product, so I have to use the product rule, 6x squared times y. Let's see. 6x squared times y. So I'm going to use the product rule, so I'll take the derivative of the first term. Or we'll do it like this. First times the derivative of the second. Alright, and so when we're taking these derivatives, we're taking it with respect to y. Sorry, with respect to x. So if you encounter a y, you then have to use dy dx. So when I take the derivative here, that would be 1 dy dx. Alright, so first times the derivative of the second plus the second times the derivative of the first. Because this is an x, we don't need this part right here. Alright, then we move to the next part. This is a constant, so that would just be a 0. We move to the next term. This is also a product, so we'll say first times the derivative of the second. The derivative of y squared would be 2y dy dx. Because this is not an x, we have to include this portion right here. Plus second times the derivative of the first. Alright, now that you have those derivatives taken, we're going to simplify and we want all the dy dx's on one side. So I have 6x squared dy dx. I'm going to move this one over, so that'll be plus 14xy dy dx. And then I'll leave everything else on the other side, so that'll be minus 12xy plus 7y squared. That should be a minus, that should be a negative. Sorry, that should be a negative right there. Okay, then we pull out the dy dx because that is common to both terms. And that'll leave us 6x squared plus 14xy. It's negative 12xy minus 7y squared. Then I divide so that I can get that dy dx by itself. So then we find that the derivative with respect to x is negative 12xy minus 7y squared all over 6x squared plus 14xy. So when you're taking the derivative with respect to x, and you encounter some variable other than x, you have to include this d, whatever that variable is, over dx. You'll take care of all of those, then isolate the dy dx onto one side, get it by itself, so that you can solve for it.